Talking about cube roots there. Now, if you look at our square root one, so let me just jump back up here. Remember with the square roots, we had this hard stop at 0 because you can't take the square root of a negative number. Can you take the cube root of a negative number? Yes. So this one is going to go on forever in both directions. There is no hard stop here because you can take a cube root of whatever you like. So if I want to graph this and I don't know how, let's again just start at 0. If I plug in 0, what's the cube root of 0? 0. So my first dot is still at the origin. That's a common trend, right? They're all starting at the origin. All right. Well. Whoa.
Come on, Katie, let's go. What are you waiting for?
What's... Oh, sorry.
Square roots and absolute values?
We're doing parent functions.
Wow.
Yeah.
Did you learn anything from the center? No? I didn't do any of them. It's okay.
So, cube root of 0 is 0. What's the next nice thing that I could take a cube root of? 8 is a good one, but there's one before it. 1, right? What's a cube root of 1? 1. So when I plug in 1, I get out 1. And then, Gabby's right, I can plug in 8 also. If I plug in 8, what comes out? 2. So 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. However, let's not forget about the negative direction. You can take cube roots of negative numbers. So the first nice number this way that you can take the cube root of is just negative 1. What do you suppose is the cube root of negative 1? Negative 1. So negative 1 is another point on your graph. And then the next nice number is now just going to be negative 8. What's the cube root of negative 8? Negative 2. Yeah. So 1, 2, 3, 4, 5, 6, 7. So this is what the cube root graph looks like. It's going to keep going forever in this direction, and then it does this little wiggle jiggle, and then it goes forever this way. So it's kind of like, let me sort of smooth them out a little bit more. It's like a stretched out letter S, kind of. So it's similar to square root, but it goes on forever in both directions. And then these two are also symmetrical to each other. So whatever it's doing over here, it's sort of mirroring it over here. Isn't that something? Okay, and one more just to make our list complete. We actually probably should have done this one first because it's literally the most basic. What if you just had a linear function? Y equals x. What does that look like if you graph it? It's a straight line, right? So it's the straight line that goes through the origin and just goes up 1 over 1. Okay, so these are the parent functions for these certain ones. Now, you want to be familiar with them. You want to be able to reproduce these. So, if I say to you, okay guys, graph me, the parent function for the square root, y equals square root of x, you should be able to reproduce this graph. Do you need to memorize the graph? No, of course not. You can literally just, if I give you this equation and you don't remember what it looks like, just plug numbers in. That's all we did to make them, right? It's helpful if you are like, oh yeah, that one starts at 0. And then, okay, what are the other numbers? Well, let's see, square root of 1 is 1. I'm not going to do the square root of 2. Let's jump to the square root of 4. And you just recreate it that way. You don't have to memorize it. It's just helpful to know the shape. Like, it's good to know that a quadratic comes out to be a U shape. So you know what you're doing. It's helpful to know that the absolute value is the sharp V. Okay? So what we are going to do, I think we'll probably start with quadratics today. We're going to take this parent function, and we're going to pick it up, and we're going to move it around the graph. And we're going to see what that does to the equation, how this changes as you move this around. Does that make sense? I'll take your silence as a yes. That sounds great. Any questions so far before we start doing anything? All right then. Well, actually, why don't we do a little... I'll do a little demonstration for you. See what you think is going to happen before we get into any of it. Of course this one doesn't work. Do you work? Your batteries are low. How about you? No. All right, we'll try this one. Okay. Alright guys, so let's say I wanted to graph y equals x squared. So we already know what it looks like. We just graphed the quadrat or the parent function. I know it should have its vertex at 0, 0, and it's going to be a parabola, right? Let's see. So there it is, everything that I thought it was going to be. What do you think this graph will look like? What if I take that same parent function x squared, but then I add 5 to it? What do you think would happen to this graph? Higher. So you mean like pick it up and move it up? Good thought. Any other thoughts? What might happen?
Steeper.
Steeper. So instead of being like a normal U, now it's going to be a narrow U maybe?
Sure.
Maybe. Any other thoughts? What might happen if I add 5 to this? Well, let's see. So when I hit graph, it'll show you the original, and then it'll graph the new one. So there's the original, and now, ooh! Christina was correct. It shifted the whole thing up 5. How interesting. So, what do you think if I had done -5, what would have happened? Yeah, it's probably going to bring it down. Let's try it just to be sure. So now it's going to graph the first two, and then it'll graph the last one. So there's the first two, and then the last one. Well, there it is. So, okay, that seems easy enough. So if I want to move a graph up or down, I just add or subtract whatever I want to the function. How do you think I'd move it left to right? What do you think I would do to the equation to pick it up and move it to the left or to the right some amount? Change the value of x. You're not totally wrong. I do have to do something with the x. Any thoughts on what? Yeah. Well, give me, or does anyone want to guess maybe something to put in here? Like, what could I do? 2x squared. Let's see what that does. 2x squared. All right. My calculator's missing a pixel right there, so it really does say x. I know it just looks weird. All right, let's see what that does. So there's the original, and there's my new one. So that looks like what Ryan had thought, making it more narrow. So it didn't move it left to right at all. It just made it more narrow, which makes sense. Do you remember? Remember the value of a did all those things? It made it wide or narrow? Do you remember that? Okay, so I need more guesses.
Wait.
Yeah.
Did you say like 2x squared plus 2x?
Oh, interesting. Interesting. So you want to add like 2x? Like that? Oh, I guess I need the original. What am I doing? Let's see what that does. So x squared, and then let's add a 2x. So there's my original. It did move it, but it moved it it moved it left and down. It's kind of interesting. But I want to merge what you both said together. So check this out. If I did, instead of just squaring x all by itself, what if I added or subtracted something to the x first and then I squared it? So like this. Say I did x plus 4 and then I squared it. Let's see what that would look like. My goodness. Wow. It appears as though I've moved it where? To the left 4. Yeah.
But if you did like, wait, can you go back?
Yep.
So if you did x squared plus, like if you just like merge that together. So I can't. If you did x squared plus 8x plus 16, it's the same thing, and it's the same thing.
Okay, so it's going to have the first two graphed, and then it's going to graph the third one. So if the second and the third are the same, it'll look like there's not even another graph. You know what I mean? So let's try it. Let's see what happens. Now, here's the hard part, though. So if I'm looking at this, there's not really a nice clean way for me to know that this third line just meant, hey, move it to the left 4. But if you look at the second line, well, at least there's a 4 in there. The only confusing thing is that it says plus 4. So plus 4 normally you think means move to the right. But there's an equation, I'll show you why. Because that's a plus 4, it actually means go left 4. So what do you think if I had changed that to a minus 4 in there? Do you think that that would just move it to the right? Yeah, it probably will. Let's try it. So now there's a minus. So I'm hypothesizing that it will be my same parent function, but now I'll move to the right 4. So there's the parent, and then, yes, there it is, move to the right. How interesting. So if I wanted to move it up or down, up I just add something, down I would just subtract, but if I want to move it left or right, what we just figured out is that I have to not only put it in there with the x, but it's really kind of the opposite of what I want to do. How about that? So that's basically what we're going to be looking at over the next couple days. Where do you put the numbers? What do the numbers do to the graph? How can I make it what I want it to be? So, maybe I should give you the formula on the notes first. Yeah, and then we'll try some. Yeah, let's do that. Okay. Wow, what did she give me? Oh, I think it's 2 pages. That's what this is. All right. Okay, so a little bit more notes and then we'll practice them. So we have let's call this formula for quadratic functions. So here's what it looks like. Let's zoom out a bit. Y equals a times x minus h squared plus k. Hold on, that k doesn't even look like a k. K. All right. So let's talk about what all these letters are. A, you already know A from way back when. A told us wide, narrow, and it also, remember if A was positive or negative, that did something? What happens if A is negative? It's flipped upside down, right? So if I ever have a negative A value, any of my parent functions would just flip upside down. All right, so A, same thing as it's always been. So this tells us wide, narrow, and if it's up, for quadratics anyway, it's up like a cup, and if it's negative, it's down like a frown. Okay, so that's old news. We've already talked at great length about that. We will look at those in a bit. H and K, though, this is sort of new. We haven't really seen these before. What is up with that? Well, H and K. Here's the first cool thing. H comma K is your vertex or your starting point for whatever your graph is. So H comma K is the vertex. Oh, wait. You did see this. Because didn't we did it in, whatchamacallit? Vertex form of a quadratic. Remember you were able to just look at the quadratic and know where the vertex was? Yes. Yes. What's nice, though, is that this same idea will apply to all the other graphs, too. So we haven't done vertex form on a absolute value, for example. But it all works the same way. So whatever H is, comma K, will always be my vertex. Whether I'm doing a quadratic, absolute value, square root, doesn't matter. Okay? So HK is the vertex. H tells how many units to move left, right. And K is units up, down. Okay, I forgot that we did this with the quadratic, so this one will be super fast. So maybe we'll even get to the, maybe we'll do absolute value after this. All right, so let's try some. Let me give you this sheet. We'll do a couple practice ones out, make sure that we know what we're talking about. So it's 2 pages. They are not stapled. What did everybody do for New Year's?
I stayed up till midnight to save you.
You did?
Yeah.
That's good. I even made it to New Year. I couldn't
Where's the
believe it.
process that?
I did fall asleep at like 10. But then I got up. Well, I was putting my son to bed at 10 because, you know, what almost 3-year-old doesn't stay up till 10. Gosh, this kid's crazy, I tell you. It was a struggle this morning. make sure you have one of each page.
Oh, wait.
All right, so if you remember how to do these, that should be super quick then. So if we just look at the first one, all right, so remember, I can just look at this and figure out what the vertex is. It's always the opposite of this number, that's our H value, and then the K value is over here. So the opposite of this one, comma, whatever that one really is. So your vertex would be at +2, -4. Is that okay? Are you remembering this? So I start at 2, -4. And then do you remember how to graph after this? You're basically going to look at whatever A is. In this case, A is 1. So, do you remember the pattern when A is 1? Where do you go? Up 1 over 1 on both sides, and then I go up 3 over 1. Okay, now this is the same thing. If you look at our parent function, I literally took the parent function, I picked it up, and I moved it 2 units to the right and 4 units down. So if you can graph a parent function, you can graph any of these other ones, because they all work the same way. You're just picking it up and moving it. Okay, so you graph number 2 for me, please. Where is my vertex? Ashley? 2, -1. The opposite of what you see in there with the X, comma, whatever this really is. So +2, -1. There's my vertex. And then again, since A is 1, I just follow what my normal parent function is. 1, 2, 3 over 1. And make my nice graph. Okay, easy enough? So let's make things a little bit more challenging. If you flip this paper over, yes. Oh, you know what? I wish there was one. Is there one on the second page maybe? Ah, yeah, actually, can you jump to the second page and let's do maybe number 11 before we change the value of A too much. All right, so if you're looking at 11, where's my vertex going to be for this? -4, 3. -4, 1, 2, 3. All right, but now A is -1. So what does that do to everything? Where do I go from here now? Down. Instead of going up 1 over 1, I go down because everything's flipped over. So I go down 1, and then I'll go down how many? 3 over 1. That's it. So if A is a negative value, remember you just go down instead of up. Okay, easy enough? So now if we could jump back to, sorry I keep making you go every which way. Let's go to number 6. All right, so now I've encountered one where A is no longer 1 anymore. Do you remember what this is going to do to my graph?
Make it wider. Narrower.
Yeah, it makes it more narrow. The only way to make it wider is to have an a value that's what? A fraction that's less than 1. Yes. Okay. So I'm expecting this to be a more narrow graph. You're still going to start off the same way. You still know where the vertex is. That doesn't change. So your vertex would be at 4, -3. Absolutely. So what does change now is that I don't just go up 1, up 3, up 5. I have to multiply all those numbers by 2. So our normal pattern is up 1, up 3, up 5. But now I'm going to multiply all them by 2. So, times 2, times 2, times 2. So I'm really going to go up 2. Then I'm going to go up 6, and if I still had space, I'd go up 10. Remember how that pattern worked, right? So now I go up 2 over 1 and mirror it on the other side. Then from that point, now I go up 6. 1, 2, 3, 4, 5, 6. And of course I don't have room to do 10, but if I did, that's what I would do. And this, yes, has created a more narrow graph. And all my pieces are in the right spot. So let's connect this into a nice smooth curve. So let's jump back to 5. What do you think having a 3 out there is going to do?
Multiply it all by 2.
Right, so this graph will be even more narrow than the one that we just did was. So go ahead and you graph number 5. Figure out where the vertex is, and then see if you can handle that multiplying it by 3 part. Do you have a beautiful graph? Where's the vertex? -1, -2, correct. And then because A is 3, instead of doing 1, 3, 5, I'm now multiplying all of these by 3, so I'm going to do 3, 9, and then I would do 15 if I could, but I can't. So I go up 3, 1, 2, 3 over 1. So please check that you have a dot at 0, 1 and at -2, 1. And now I'm going to go from the point that I just made, I'm going to go up 9 over 1. So your next 2 dots, you should have one at 1, 10. And another one at -3, 10. And that's as much as I can fit. Smooth curve as best I can. There it is. So tell me what 7's going to look like.
Down.
It's going to be down and more narrow, okay? Try 7, and then I think we might, I think we should do absolute value today, and then we'll be done. We'll do the first part of absolute value. Because there's a second part that's kind of tough. Hurry! Okay, everybody's got 7? Vertex is at? 4, -1. And then I just follow this. Since it's -2, I'm going to go down 2/1. And then I'm also going to go down 6 from that point. So 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. There should be your graph. So make sure your vertex is at 4, -1. Then your next set of points should be at 3, -3, and 5, -3. And then these ones are at 2, -9, and 6, -9. Everybody's okay so far? Yeah? Okay. So I'm going to give you the next sheet, but I think, let me see. I'm going to have you, I'm going to have you finish the rest of the graphs. So if you want to do a couple while I'm handing that out. On this sheet, we're not going to do all of them. I'll just do a couple. Oh, is this 2 pages too?
Maybe. Yes. Well, there is a second page on you too. Okay, so let's look at the absolute value ones. And you're going to see how similar it is to the quadratic one. So check this one out. Y equals A, absolute value x minus h plus k. Guys, it's almost the exact same formula. It's just that instead of it being a quadratic, it's now just absolute value. So all the things are the same. A still tells me wide, narrow, upside down, or right side up. So A, wide, narrow. It's just that these are V-shaped, so it's either going to be up or down. And then my vertex is still at h comma k. Okay, so if you look at the sheet that I just gave you, let's see if we can figure these out. Oh, for Pete's sake. There we go. Okay, if I'm just looking at number 1. Actually, let's not look at number 1.
2. Let's start with 2. Who can tell me what the vertex is of this one? Knowing it follows a very similar pattern. What must H be? H is always the thing in there with the X, yeah. -2, and then K is 4. So just like when it was a quadratic, it's always the opposite of the thing that's in there. It still is. I want the opposite of this thing, comma, that thing. And there's my vertex. So, vertex this time will be at -2, +4. Is that okay? Just like it was with the quadratics. Ryan's got it. Yep.
So, for the absolute value, watch the first number would always be negative.
What do you mean?
Like
I'm
the first
confused.
number in the vertex, it would always be negative.
Unless that was a minus sign.
But wouldn't that change into positive since it's
No, so it doesn't have anything to do with, you're not actually taking the absolute value of this. It just, the absolute value is just means that it's going to be a V shape. So your vertex will always, whatever this is, regardless of whatever's around it, it's always just the opposite of whatever you see there. And that's just always what it is. All right, so this one is at -2, 4. Okay, and now this is an absolute value graph. So if you remember what the parent function looked like, here it is. And to get the other dots, you just go up 1 over 1 all the time. So it's not the 1, 3, 5 like it was with the quadratics. It's always just up 1 over 1. So that's all I have to do. I'm just going to, from the dot that I just made, I'm just going up 1 over 1 on both sides. Because it's going to be this sharp V. It's not changing. Does that make sense? Is that okay? So once you figure out where the vertex is, now you just say to yourself, okay, this is an absolute value, so from here I'm just going up 1 over 1. So let's now rewind back to number 1. Bless you. Where would your vertex be for this one? -1, comma 0. There is no number out here for K, so it's just a 0. So yes, -1, 0 is where my vertex is. And then I just follow my absolute value pattern, up 1 over 1, that's it. Okay, let's jump down to 3. Where's my vertex now? Yep. Thank you. -2, comma +3. -2, 1, 2, 3. Now, however, A is negative. So what is that going to do to everything? Where do I go from that vertex now? I'm just going to go down instead. So I'm going down 1 over 1. That's all. Okay. Now, let's see. Do I want to do the tougher ones? I guess I'll hold the tougher ones till tomorrow. Because what happens when A isn't 1 anymore? It's going to make it narrow or wider, but we'll touch on those tomorrow a little bit. Okay, so here is what I want you to do for the rest of class and for, I mean, there's no reason why you shouldn't finish. But on the sheet right here, the absolute value one, I just want you to do numbers 4 and 5. So that should take you all of 2 seconds. And then on the other page, the quadratics, I want you to finish the rest of them. So there's not that many. There's So you have 3 and 4 and 8 on the first page, and then on the second, 9, 10, 11, and then 13 to 16. Okay.
Are we out to go on the board with CJ?
Well, how are you gonna graph on the board though? You can, yeah, but how are you gonna redraw every single one on your paper? That seems to be counterintuitive. Yep.
Can you put the notes back for asset value?
Yes, sorry. What you can do if you want is you may go work with someone if you want to.